Hello everyone. Today I'm going to talk about how we can utilize new project execution and technology to make marginal time of fields and projects for prolonging life of installation more profitable. In order to do that though, I firstly want to state the obvious. In order to have a high efficiency operation in terms of energy and cost, good planning is required. It needs to be built right the first time. We need the plant to be built in an energy efficient manner. This is important both for the environment and the cost. And last but not least, we also need a high degree of automation if we are to keep the costs down. Preferably, it needs to be fully automated. All of this is nothing new though. It's what the industry has been chasing for years, and it does change the challenge somewhat, because it's then down to how can we ensure that we follow and excel at these points. Traditionally speaking, the plant is designed in multiple disciplines: process, automation, mechanical, safety, structural engineers, etc. However, they have never truly collaborated, or at least not at an early enough stage where their feedback leads to design changes as opposed to design workarounds, as their feedback typically come into the loop too late for it to have any good effects on the design. The solution to this is a collaborative environment where a digital twin can become a complete virtual representation of the asset as early as the ambitions is for cost reductions and automation requires. Through the Cognitwin solution, an environment where all systems and disciplines are included, considering their physical presence, the system functionalities through dynamic simulation, automation, and safety systems completely virtualized. It means that at the front-end engineering design stage, the complete design can be verified and optimized already, proving the design way before it's being built. Through the 3D model, the asset can be analyzed and ensure that the plan can actually be built in the planned fashion, and the potential maintenance mission can be executed efficiently once the plant is in operation. And the key takeaway here is to make the relevant information available to the disciplines that needs it, while also sharing their requirements back to the disciplines designing the underlying or neighboring systems. Through a dynamic simulator at the core of the digital twin, the entire design can be validated and optimized. Starting in the early concept phase, the concept can already be thoroughly evaluated, not just by process engineers. For example, automation engineers can explore the proposed design from a control design perspective, ensuring that the right concept is selected to enable the highest degree of automation. Moving closer to the end of the feed, the front-end engineering design stage of the project, when the concept is more or less set and the design is maturing at a high pace, the multidisciplinary team continues their collaboration and are all aware of all design changes happening due to certain equipment being chosen. For example, the vendor chosen for the compressor decided upon to meet the process requirements, which may completely change the need for utility systems or maintenance, which in turn has an effect on automation. If this isn't identified early enough in the project, it might cause serious workarounds that affects the overall profitability. Once all of these decisions are set though, the final design can be thoroughly evaluated before it progresses to the detailed design phase. This means that for a field that has slim margins and depend on a perfect design with a high degree of automation to be profitable, there is no room for design mistakes, and the design needs to be as optimal as possible. On the positive side though, given today's technology, it is possible to do a complete virtual evaluation of a finished design before it's built. For example, a digital twin can be used to do a virtual commissioning of an unbuilt plant on a dynamic simulator, including all control logics, safety systems, to ensure a smooth and optimal operation, fully automated, keeping the dream alive of a one-button startup. When the plant is in operation, the virtual asset can be further utilized by tying back real-time data to the operating plant, using the dynamic simulator to gain insight for further optimizations, maintenance planning, upgrade evaluations, and even virtual measurements or performance monitoring. By moving everything in the project execution phase earlier, the entire plant can be digitally and virtually tested at the feed stage. This vastly increases the predictability of the remaining project period. Kongsberg Digital's Cognitwin is a tool that enables these features, with simulation at the core and collaboration at scale. Through this, we have created a solution that enables all disciplines to contribute with their specific knowledge into a virtual representation of the asset that is to be created and maintained, ensuring that the people share their knowledge and the insights about the design at the moment it's being discovered. And I think that we can all agree that it's much easier to solve a problem if we can have it in front of us. This is what the Cognitwin is all about. Collaborating around the same challenge to enable the best decision every time.